Welcome. Today we're going to learn how to simplify a radical expression. Now, all a radical is a root. We're going to specifically do square roots. And you should be very familiar with doing square roots of perfect squares. If I gave you the square root of 36, you should be able to tell me that's 6. But we're going to do more complex radicals where it doesn't square root evenly. Now, we don't necessarily want to use a calculator and get a decimal. What we want to be able to do is basically simplify. Very similar to if I gave you the fraction of, let's say, 8 over 12, you would never leave a fraction like that. You would say, hey, 4 goes into both 8 and 12. That reduces to 2/3. That's simplifying a fraction. We're going to do the same thing with square roots. So let's start out with a very, very simple one. Let's do the square root of 8. Now, the square root of 8 isn't a perfect square, or 8's not a perfect square, so it doesn't have a perfect square root. But it does have a factor that is a perfect square. What I mean by that is what we do is we break down that 8 into its factors. So like two numbers that multiply to give you 8 are 4 and 2. 4 times 2 is 8, which then we can separate square roots into its factors as separate roots. In other words, I can separate that 4 times 2 that's under one square root under two square roots. Square root of 4 times the square root of 2. Well, the square root of 4 is a perfect square. I can square root it and get 2 times the square root of 2. You don't need to put a times symbol there. We just write it like that. And so the square root of 8 reduces to 2 square roots of 2. Now, I do want to emphasize that a lot of students end up breaking it down further, and they say 8 is a 2 times a 2 times a 2. Well, then what we do is we pair up numbers because that makes a perfect square. We pair up the 2's to get our square root of 4, and then we have that one square root of 2 left over, and we get the same 2 square roots of 2. Let's do another example. Let's do something like the square root of 54. Again, 54 is not a perfect square root. But what we're going to do is we'll start to break it down. And I always do whatever is the simplest. In other words, if you're unsure what multiplies to give you 54, I notice it is even. So I'm going to break it down to a 2 and then whatever 54 divided by 2 is, which is going to be 27, I believe. So 27 times 2 is 54. But neither of these are perfect square roots. So again, I break the 27 down further. So if it will anyway, and I should realize it's divisible by 3. So I'm going to have that 2. I'm going to have this a 3 now. And then what's 27 divided by 3? It's 9. So 9 times 3 times 2 should give me 54. But now I'm going to stop there and think, hey, I have a perfect square. I'm going to separate the square root of 9 from that square root of a 3 and that 2. I'm going to leave both the 3 and the 2 underneath because they're not paired up. They're not perfect squares, but I'm going to leave them both under a single square root. Square root of 9, though, is 3. And then I'm actually going to multiply the 3 and the 2 back together because 3 and 2 are prime. They can't break down any further. I get the square root of 6. So 54 reduces to 3 square roots of 6. Let's do another one. Now let's say there was something on the outside of the square root. Let's say there was something like 3 square roots of 98. Okay, 3 square roots of 98. Now that 3 means I'm multiplying by the square root of 98, or square root of 98 times a 3. So I'm just going to leave it out front. I'm going to have a 3 times the square root, and I'm going to still break up that 98 into smaller factors. Now again, if it's hard thinking of what multiplies to give you 98, start with a 2. and 2 does go into 98. So I'm going to have a 2 times, and now I'm going to do 98 divided by 2, and I get, of all things, 49. Oh, 49 is a perfect square. So what I'm going to do is I'm going to leave that leading 3 out front. I'm going to separate the square root of 49 by itself and the square root of 2. So I've broken that single square root into 2 square roots, one of 49 and one of 2. And then what's the square root of 49? It is 7. And then this times the square root of 2, because I can't square root the 2. It's not a perfect square. 3 times 7, one last thing to do is multiply those things on the outside, 21 square roots of 2. Now be very careful that you multiply that 7 that came out from underneath the square root by the 3. A lot of students accidentally add it and would say 10 square roots of 2, but it's 7 times 3. Let's do one more, and hopefully this will be enough to get you going. And if you have questions, you can always bring them to class. Let's do something like, I don't even care, 5 times the square root of 72. Okay, 72 is not a perfect square. So the first thing I'm going to do is I'm going to start to break that 72 down. I'm going to leave the 5 alone out front, and 72 is even. So I'm going to break it down to a 2 times and then take my calculator, whatever you need to do to divide 72 by 2, and I get 36. Now hopefully you recognize 36 as a perfect square and you just stop breaking the 36 down. But again, you could actually break that 36 down into a 6 times a 6, and then we have that 2. And you could break down the 6's even more. You could have that 5 out front, and then each 6 breaks down to a 2 and a 3, and a 2 and a 3, and then that last 2, right? So there's 6, there's 6. Oh, you can't quite see that. There we go. So there's 6, and there's 2. And again, what you would do if you broke it down that far is you would pair up the 2's. Remember, we can use the commutative and associative property to rearrange this. So what I would do is I would break it up into a 2 times a 2 under one square root times the square root of 3 times a 3 under the other square root. So there's the 1, 2, and the other 2, and then I put the 2 3's under that one. And then that odd third square root I'll leave there. And again, what's the square root of 4, or when I combine that together, that becomes a 2. What's the square root of 9, or when I combine the 3 and the 3, that's 9. Square root of 9 is 3. That doesn't have a pair to it, so I leave it under the square root. And 5 times 2 is 10. 10 times 3 is 30 square roots of 2 would be your final solution. Again, hopefully you would have stopped back here and did it as 5 times the square root of 36 times the square root of 2, and then square root of 36 is 6 times the square root of 2, and then 5 times 6 again is your 30 square roots of 2. Same exact answer as the one we got there. I just wanted to show you both ways in case you break things down too far that you pair things up to get perfect squares. If you have questions, please bring them to class.